Good day, students. Today we're going to look at our lesson on differential equations. The notes that I'm going to share with you are available on Canvas as always, and again, you are encouraged to get these problems done through the assignment on Canvas before class next time. We're just going to do some examples. So the first concept I'd like to review on differential equations are slope fields. So here we have a differential equation, dy over dx equals 2x minus y. And we're asked, this is an actual AP exam problem from 2015, we're asked to make a sketch of this slope field. So let's just pick this point right here. Let's do 1, 2. We're going to look at the point 1, 2. So what we're going to do is we're going to evaluate dy dx for that. So we're going to do 2 times 1 minus 2. So I plugged 1 in for x and 2 in for y. And then this is clearly going to be equal to 0. So that means the slope of that particular point is 0. I didn't do a very good job of that. Let's try that again. It's a horizontal line of 0. Let's do one more point. Let's do this point down here. Let's do 0, -1. So that means that dy dx, which if you think about it, derivative is the slope of the tangent line. So the slope here kind of makes sense. That's what this 0 is. That's the slope of the tangent line. So if we do 0, -2, that's going to be 2 times 0 minus 1. So the slope there is going to be 1. So the slope down here at 0, -1 is going to be a slope of 1. That's better. Okay, next example is solving a differential equation. So here we've got a much more complicated looking equation. The first and most important step here, which you guys probably remember me talking about a lot, which is something called separation of variables. So you can see that I've got x's and y's on both sides of the equation. So we can simply cross multiply here, get all the y's on the left side of the equation, and then all the x's on the right side of the equation. So how do we undo differentiation, which is what a differential equation is? Well, we're going to integrate. And when you integrate 2y, you're going to get y squared. When you integrate cosine y, you're going to get sine y equals, and then when you integrate 6x squared, you are going to get 2x to the third plus c. And I think I'll call it a day on that one. I wouldn't solve this for y. In fact, I'm not sure that you can solve this for y. Okay, the next equation we're going to look at, forward here, we're still going to solve another differential equation, but this one I'm asking you to get the particular solution. So here's the differential equation. You can see that the differential part is right here. And we're given that the initial condition is 0, 6. So I'm just going to go ahead and start working here. I'm going to change that y prime to dy dx. And I'm just going to go ahead and move that 2e to the x over to the other side by addition. Still got some x's and y's mixed up, but I can just multiply the left-hand side by dx. Then I have to do the same thing on the right-hand side. So now I got all my x's and y's on different sides. So again, this is that separation of variables, very important step. Now we're going to integrate. The integral of y, I think that's going to be y squared over 2. And then the integral of 2e to the x, I think, is just 2e to the x plus c. So this is the general solution. We're asked to find the particular solution. So let's see if I can change colors here. So now we've got to plug this y naught equals 6 in to find what c is. So y is 6, so we're going to put 6 in here for y, and we're going to put 0 in here for x. So that's going to give me 6 squared over 2 equals 2e to the 0 plus c. So that'd be 36 divided by 2, which would be 18 equals, and then that'd be 2 times, and e to the 0 is 1, so that's 2 plus c. So c is equal to, that looks like 16. Okay, so let's go ahead and write our final answer then. I'll do it in green. Final answer could be written as y squared over 2 equals 2e to the x plus 16. Or if you wanted to clean it up a little bit, you could say that y squared is equal to 4e to the x plus 32. And I guess we could go ahead and solve it all the way down for just y, but I'm running out of room, so we'll stop there on that example. Okay, timing is looking good so far. We're at about 6 minutes. I've got 2 more examples. The last example, if you're an AB student, you won't need to worry about. Okay, so this example here is on exponential growth and decay, and I'm mentioning here, this is more a reminder for me than for you. And the reminder is this: if you are in BC calculus, you also need to know not only the exponential growth and decay, but the logistics equation. So here we're given some plutonium and a half-life, and we're asked to basically figure out how long it takes 100 grams to decay down to 12. So the hint I'm giving you there is that differential equation. You probably know that when you solve that differential equation, you get a very important and commonly known equation for exponential growth and decay. And so at this point here, we need to, based on the fact that we know how many years it takes to decay into half of its value, we can find k. So the first thing we're going to do is find k. So I'm going to just write 1/2 equals e to the 1, 2, 3, 4, and then k. And then you can solve this for k, and I'll let you guys work that out. K turns out to be, and this is I should have written approximately, but it's pretty close point. There's 3 zeros, 5, 6, 1, 7, and it goes further than that, but that's good enough for right now. Now that we've got k, we can use that information to figure out the rest of our answer. So now we're going to use this equation and the information that's given in the problem. So we are going to write, we want to know how long it's going to take 100 grams to go to 12, and then E, and then K. I'm going to write K up here, and then T. Now keep in mind, we know what K is. And since we know what K is, T is the only variable. And again, I'll let you finish out the work, but T turns out to be 3,774.675 years. And that should hopefully make sense, because it takes 1,234 years to get down to 50 grams, so it's going to take longer than that to get to a smaller amount. Okay, last example. The last example is only for Calculus BC students, so if you're an AB student, if you want to watch, you can, but if you're not interested, this isn't on your exam, so I wouldn't worry about it. So here we have a differential equation, and we're told that y equals f of x is a particular solution for this differential equation. We're given that the initial condition here is 0, -1, and we're asked to use Euler's method, and you can probably guess who that guy is right there. Starting at x equals 0 and a step size of 0.2 to approximate f of 0.2. So the first thing I'm going to ask you to do is, if you do not know Euler's formula, if you've forgotten it, I would encourage you, go review this formula. If you don't know it, you need to review it, because if you don't know it and it's on the test, you're going to miss that. And it's not hard, it's easy, but if you don't know it, you're in trouble. So y prime of 0, -1 is going to yield 2, and that's using the differential equation above. Then using that information, we can say that f of 0.2 is approximately negative 0.6. Now we use that information and we'll say that y prime of 0.2 negative 0.6, that ends up giving us 2.8. And then that gives us our final answer here, which is going to be that f of 0.4 is approximately, oops, that's approximately negative 0.04. That's your answer. I'm at 10.5 minutes, so I need to stop there. Thanks so much for your time, and have a good day.